Hi everybody, and thank you for joining this session. My name is Evgeny Vaganov. I'm a head of networking solution architects at AWS. In this role, I work with customers across Asia Pacific and Japan, and I often discuss with my customers about how they can transform their global network on AWS. In this session, I'm going to share what I have learned from this discussion so far with you. I have a lot of ground to cover in the next 30 minutes, so let's get going. To set your expectations, I will spend a few minutes introducing the problem space and associated challenges. After that, I'll go over AWS Global Infrastructure and how services such as AWS Cloud WAN and AWS Direct Connect Site Link can help you transform your network. I'll conclude with a summary of this session. As a quick reminder, this is a 300-level session, so I expect you to have a solid networking background and knowledge of AWS services such as Amazon VPC and technologies such as VPN and routing. I'd like to start by walking through a modern network. A modern network often follows a hub and spoke topology. A data center in the middle is a hub connecting remote sites and branch offices through a variety of technologies, such as IPsec VPN, list lines, and MPLS. And if this network operates across many geographic locations, such as different countries, you'd have more than one hub. You're also likely to use different telecommunication providers in different geographies, and even bring different technologies, such as SD-WAN, to your site connectivity into the mix. And finally, you often have another network to connect your hubs. This transit network may end up using yet another carrier. In the network I described just now, there are a number of challenges, from long-term commitments to carriers, to complex mix of technologies, to careful compatibility considerations. All of this result in a need for specialists to run such a network. And finally, this have impact on cost through high operational burden and overheads. And actually, your global network in 2022 is a lot more complex than what I have shown so far. Since you're listening to this session, you likely have AWS Cloud and associated hybrid connectivity. And it might be in more than one AWS region. And again, there's a mix of technologies used for AWS hybrid connectivity, from AWS Direct Connect to site-to-site IPsec VPNs. And you may also have a lot of users connecting remotely, some to your traditional data center hubs, and others direct to AWS Cloud. And you can see complexity keeps increasing, and at some point you need a reset. There is another trend here. More and more applications are moving from your on-premises data centers to AWS Cloud. As more and more applications move to AWS Cloud, it no longer makes sense to connect your sites and users to data centers. This is because traffic makes a necessary detour via data centers instead of going to applications directly. Look, global networks can be hard. And if you feel that global networks are hard today, you're not alone. I feel the same way. So, you need a reset. The way you think about global networks. Perhaps even connectivity in general. And AWS can help. AWS has the largest global infrastructure of any cloud provider. And this infrastructure, including regions, local zones, edge locations, is connected by AWS Global Backbone. This is the backbone that powers AWS, Amazon.com, and every customer who runs their workloads on AWS Cloud. Historically, customers would use this global backbone to connect workloads in different AWS regions. But AWS is seeing more and more customers using this backbone for inter-branch and site connectivity. Before I jump into technical details on how that works, I'll list the benefits of using AWS to build your own global network. Networks built on AWS follow the same flexibility benefits made available by the cloud. No long-term contracts and ability to provision new sites in minutes. You can use the power of software-defined network, similar to how your DevOps engineers deploy applications in CloudFormation and Terraform. Creation and modification of network resources is based on API calls. AWS has a broad ecosystem of partners which allow you to bring your own network appliances and AWS has also many connectivity partners, giving you more options. You end up benefiting from cost savings of AWS scale and also usage-based pricing. And you benefit from consistent security and observability throughout your global network on AWS. Here's one example of a customer in Australia who has already transformed their global network. Sportsbet, a division of Flutter Entertainment, they were able to achieve better latency and jitter variants, while at the same time benefiting from elasticity. This translates to being able to pump gigabits of traffic through the network to other divisions during their busiest events and have access to data feeds from overseas. All of this with much larger volume of data enabling analytics and use cases not possible before. By now, you probably really want to understand how to get started. So let's get to it. One way to build your network on AWS is by using every AWS service like a Lego block. Let's say you already have a couple of AWS regions and a few VPCs. While you can connect them using VPC peering, what really unlocks global networks on AWS is AWS Transit Gateway. It acts as a network hub, and you can peer them just like you would peer your core routers in a traditional network. Transit Gateway allows traffic to transit from one location to another with flexible routing. For example, you can build centralized internet ingress and egress for your VPCs and other networks. Transit Gateway also used as a termination point for your site connectivity, be it branches or data centers. You can advertise a default route to your sites and bring traffic into Transit Gateway. You can also use the network to access various SaaS applications via AWS Private Link. You also have an option to insert firewalls between networks as you see fit. There are, however, a lot of moving parts here. Some static routing involved, and you need both networking and AWS Cloud expertise to make it work. We've heard from AWS customers that they want an easier way to build global networks. That's where a new service announced in preview in December 2021 comes in. Please welcome AWS Cloud WAN. It comes with many benefits of simplification while allowing better segmentation and visibility throughout your network. With Cloud WAN, you start by creating a global network. Within your global network, you define a core network. This core network consists of multiple core network edges connected together. Core network edges are essentially your data plane. You should pick core network edges based on your geographic locations of AWS regions, your sites, and remote users to ensure lowest latency possible. Once you have the core network, you can attach your sites and remote users. Your network is likely to have segmentation requirements. For example, users are allowed to connect to other users, and your factories should be isolated in its own segment. Cloud WAN allows you to achieve these requirements. You define your segments, routing between segments, and can even insert network firewalls into the traffic path based on global network policy. A single document which manages the entire network. Once the network has been created, Cloud WAN generates a complete view of your on-premises and AWS networks to help you monitor the network health, security, and performance. Let's now go into more details on how Cloud WAN works. Cloud WAN is managed from a centralized control plane. The data plane component, called Core Network Edge, is provisioned in the AWS regions you select. Core network edges are connected together, and routing information is exchanged with the dynamic routing protocol out of the box. You can leverage inbuilt automation to attach your things. For example, you can attach your VPCs, IPsec VPNs to connect branches and data centers. You can attach SD-WAN appliances, client VPN services, and even firewalls and direct connect. Important to note that you can keep your existing equipment, The last mile connectivity to your sites doesn't have to change. The three most typical use cases for Cloud WAN are the following. First one is the connectivity between your VPCs. Cloud WAN really shines when you have multiple AWS regions and want to leverage automation for VPC attachments. It also has network segmentation across AWS regions, which is much harder to achieve with AWS Transit Gateway. The next use case is wide area networks. It is kind of obvious one, since it's in the Cloud WAN name. This allows you to connect your sites and leverage AWS Global Backbone while enjoying dynamic routing and segmentation capabilities of Cloud WAN. Finally, there is a hybrid. This is the mix of many VPCs connecting to many sites, which is the case for most large-scale networks. So, there are several components to the Cloud WAN service, and it does leverage the same AWS services like Managed Site-to-Site VPN and Direct Connect you might be already familiar with. So, how do you actually manage them? I already mentioned before the policy document. This document, called Core Network Policy, allows you to define all required components. For example, core network edges in corresponding AWS regions, and the required BGP inputs. All of this is done with AWS Network Manager. The AWS Network Manager gives you a dashboard for policy configuration, and it allows you to monitor topology, routing information, events in your network, and review the network performance. Let's further review different components of the network policy document. So you define your core network edge regions and the range of BGP ASNs, autonomous system numbers. You do need one ASN per core network edge. Cloud WAN takes this input and creates your core network with distributed data plane. It automatically configures BGP under the hood. In the document, you also define network segments. You provide the names and the behavior for the segment. For example, you may choose to isolate all attachments from each other within the segment. You can optionally define some sharing and routing between segments. For example, you may want to leak a route for on-prem networks into multiple segments. Finally, you can optionally add instructions to automate attachment association to your segments with rules. As example, you can automatically associate attachments to development segment based on attachment tag, where tag key is environment and value is development. In case of production, you may choose to do something similar, but require manual confirmation from an operator. And that's it. It's really anywhere from 10 to 100 lines of JSON in this policy for the entire network. Cloud WAN does the rest. How do you manage the policy lifecycle? Over time, you're probably going to make many changes to network policy to add new core network edges or new segments. Spoiler alert, it's very similar to CloudFormation experience. You generate a new policy and provide it to Cloud WAN via API or console. Cloud WAN will validate and generate a change set, which will show you the intended modifications. You can stop and create a new version if you're not happy with the results of the change set, or you can actually roll forward by executing the new version of the policy. You can also roll back to previous version. Cloud WAN will orchestrate the change across your global network while you do something else, something more important for your business. For example, you could be actually looking at your topology, metrics, and events available in Cloud WAN dashboard. Events are my favorite in this list. This is where you can see flapping BGP peers or VPN tunnels going down intermittently. It really does have a lot of things you could be looking at, including topology graphs, which are dynamically updated based on your current network state. And it goes without saying that there is a growing partner ecosystem around Cloud WAN, with many more partners aiming to make their integrations available once Cloud WAN goes into general availability. Now, I want to take you back to the modern global network slide I have shown you earlier. As you remember, there is a lot of complexity and legacy here built over time. AWS provides you an opportunity to hit the reset button and really rethink your network. And once you hit the button, the network does transform. Your network becomes simpler, and traffic from your sites and remote users now goes directly to your application in the AWS Cloud. Now, I'd like to take you through a demo of AWS Cloud WAN. I'm logged into my AWS account. First, let's open the Network Manager console by searching for Cloud WAN. Inside the console, I'll create my first global network, and within that, my core network. I'll need to give it a name, populate a range of ASNs, and also select regions for my core network edges. I'll also populate a name for my first segment. I'll call it non-prod. Once done, I'll review my configuration settings and create the global network. Okay, the network is available, and I can go ahead and explore the user interface. I can check the core network details page and confirm the status of my network. It is pending creation. I can take a look at my core network policy and review the status. I have the first version created for me and executing, meaning resources are being provisioned. I can click on my version number and review the policy template in JSON. Okay, I skipped waiting for the execution part and fast-forwarded by a few minutes. Execution is now succeeded. Let's now edit the network policy. I'd like to go ahead and use the user interface to add additional segments. I already have a non-prod segment, and I'd like to add a prod segment. I'll make it available in both locations, Sydney and Singapore. Because it's an important segment, I'll require an operator to manually accept attachments irrespective of my automation policies. I'll also add another segment for my shared services, which I'll use for centralized internet egress. And in this case, I'll let automation take care of attachment association without manual approvals. I can now create a new version of my policy. You can see the version 2 is ready, and we can view or apply the change set. Before we apply, we have a chance to review any policy modifications. And in our case, we are adding 2 new network segments. Let's go ahead and apply the change set. It's now executing. Once execution succeeded, I'd like to make another modification. What I'd like to do is to add some automation to associate my attachments to the right segment. I could use the user interface to do it, but to save time, I'll instead just edit my JSON policy template with some pre-created policies. Okay, let's go ahead and select JSON editing user interface and copy-paste in the right place. As you can see, I'm going to add 3 rules. 1 per segment to attach based on attachment tags. I'll follow the same process to review the change set and apply it, just like I did earlier. Let's go through the user interface and do the same. All right. I'll now apply the change. The change has been applied. We can take a quick look at the user interface and see the 3 rules, 1 for each segment, and any associated settings. So at this point, we are ready to create our first attachment. I have a number of VPCs created in advance. So what I will do, I'll add one of my production VPCs in Sydney. I do have to select the VPC ID, confirm attachment subnets, and give it a tag so my automation can kick in. So I'm now selecting my VPC ID. I'm confirming my attachment subnets, and I'm giving myself a tag. Once ready, create the attachment. As you remember, for prod, we require manual operator acceptance. Let's accept. And after a small period of time, we can see attachment state transitioning from pending attachment to acceptance and being created. Okay, it's creating now. I'll go ahead and add one more attachment to our shared services VPC. We'll follow the same process and confirm VPC ID, the actual subnets, and make sure to tag the attachment. In this case, we don't require manual acceptance. And you can see that right away, once the attachment is being created. So we're creating the attachment now. And as you can see on the screen, this attachment transitions to creating right away. This is all based on the automation that we created earlier inside our network policy. Okay, I'll skip the boring part and fast forward to a point where all 6 have been created and are available. The next step for me is to create a route within each VPC, which will point towards our core network attachment. What I will do, I'll show you a single route table and do the rest offline. The process of adding route should be very familiar to you. Once an appropriate route table has been identified, I'll add a default route pointing towards the core network. Please note, since the core network is a global resource, the target shows up as the full core network ARN. This is expected. Okay, I skipped to a point where all of my VPC route tables have been updated. I have an EC2 instance in each segment and each region. I'll go ahead and copy the IP address of my prod instance in Singapore and log into the prod instance in Sydney using Sessions Manager. For Singapore VPC, I use 172 range and 10 range for Sydney to make it easier to distinguish between regions. As you can see on the screen, I'm able to generate traffic between 2 instances within the same segment. I'll now get the IP address of my non-prod instance. And since this is a traffic between different segments, I don't expect it to work. As you can see, it doesn't. Next, I'll try to test my internet access. It doesn't seem to work. This is because I'm missing some inter-segment routing configuration. So, I do have my egress VPCs created and ready to go. I just need to modify my network policy. Let's once again edit the network policy to add missing configuration. What I want to do is allow my prod segment to talk to the internet. To do that, I need 2 pieces of configuration. For the first one, I need to make sure that my shared services segment can talk to other segments. So I'll go ahead and share routes from other segments into my shared services segment. The second item, I'll create a default route within my prod segment pointing towards my egress VPCs. Note, we do need an attachment in each region, as otherwise traffic will take AWS Backbone and use a different region if no local attachment is available. Let's now go ahead and create and apply this network policy change. We will follow the now familiar process and review the change set before applying. As you can see, we've got a number of configuration changes, and we are able to see all of our modifications. I'll skip a little bit ahead so that you can see successful completion. And now we can test to confirm that we have internet access as intended. As you can see, we do have internet access. To finish the demo, I'll show you a couple of menus showing our network topology and route tables. You can see both regions with core network edges. The entire topology is visualized including attachments. And we can also take a look at the topology tree. Inside core network, I want to show you one section called sharing. In the real-world scenario, you're likely to have many different AWS accounts. That's where sharing via Resource Access Manager comes in. You can share your core network and it becomes visible as a global resource once accepted in RAM. Finally, I can show you the route tables per segment. You can see routes being propagated dynamically from other regions, and static routes in prod segment, while there is no equivalent in the non-prod. I hope you enjoyed the demo and can see the value of Cloud WAN. Cloud WAN solves a lot of use cases, but there is one use case where you may want the highest performance and the lowest latency possible while leveraging your existing AWS investments. I'm talking about AWS Direct Connect and the ability to use AWS Global Backbone to connect your sites without going to AWS regions. This is where a new feature of AWS Direct Connect called Site Link comes in. It allows you to connect your sites in seconds, leveraging Direct Connect reliability and pay-as-you-go pricing. Let me explain how it works. Before Site Link, your Direct Connect was used for connectivity from on-premises networks into AWS Cloud. Connectivity between your sites was not allowed. Once Site Link is enabled on your virtual interface, AWS will re-advertise routes learned from all parts of your network back to your virtual interface. You therefore now have the ability to have your sites communicate with each other. Traffic goes the shortest path between Direct Connect location over AWS Global Network. Site Link is available in 100+ locations around the world, and AWS is investing into additional locations all the time. So how do you turn Site Link on? It's pretty simple. You can turn it on using AWS Console or AWS CLI for a new private or transit virtual interface. You can also do it for an existing virtual interface. This gives you an ability to turn it on whenever required. And so if I go back to your transformed global network on AWS one last time, you can see Site Link is also playing a role here if you have the lowest latency and highest performance use case. And all of this traffic uses AWS Global Backbone. In summary, with AWS Cloud WAN and Direct Connect Site Link, you can connect your network using AWS Global Backbone. AWS supports a variety of encryption options with pay-for-what-you-use pricing model. Cloud WAN specifically allows you to create core network, which facilitates VPC to VPC connectivity and supports VPN and SD-WAN. You can configure multiple network segments and use Cloud WAN for monitoring of your network. Keep in mind, with Cloud WAN, all traffic has to go through your core network edges, which are provisioned inside AWS regions. With Site Link, you don't have to go via AWS regions. Instead, Site Link uses the most direct path between two Direct Connect ports. AWS supports up to 100 gigabit per second path, and you can enable Site Link per virtual interface. AWS gives you many networking services to build a network to fit your requirements. More than that, you can run workloads and services whenever you need them, be it AWS regions, local zones, or much closer to the edge with AWS Wavelengths, AWS Outpost, or even AWS Private 5G. You can also have two new networking services, AWS Cloud WAN and AWS Direct Connect Site Link, making it easier than ever to hit the reset button on your network. If you'd like to learn more and continue your cloud journey, please use these training resources available via QR codes you see on the screen. Thank you for tuning in. I hope you learned a number of new things in this session. If you're interested in transforming your own network with AWS, please don't hesitate to reach out to your AWS representative or even myself. The team at AWS really values your feedback. Help us improve our sessions by sharing your rating. And enjoy the rest of your summit.